All right, welcome back to the channel. Today we are doing something a little bit different. We are going to do some car math. Not the car math like project car math, like you have one project car, you buy another car as a parts car for your project car. The parts car is better than your other one, so now you have two project cars, so you have to buy a third car. Yeah, no, not that project math. Not that car math. We're going to talk about gear ratios. How to pick a gear ratio for your application. Yeah, I'm going to get a little bit into some math. I know the word nobody likes to hear, but it's necessary. So let's get right into it. Recently, you probably saw my other videos where I'm restoring my wife's 86 C10 pickup. And I have to pick a gear ratio for the rear end. Currently has a 273 rear end in it. We're going to go up to a bigger tire size. So how do I know what gearing to put in the rear end if I change my tire size? Let's get to it. So my tire so a few things you got to pick is you got to know tire diameter, our target engine RPM. You need trans gear ratio. You need, and if you have a four-wheel drive, it's applicable to have a transfer case gear ratio. So these things are all going to be things that play into your whole thing and your target speed. So for this truck, we're going to go up to an 18-inch tire, a little bit larger tire. The tire we chose was a 275 65 18. The reason I picked that tire is because it was free. Also, the rims were free, and I think it'll look really good on this truck, just having a bigger stance. But we're going to convert that to tire diameter here in just a second. Engine RPM. What's your cruising RPM for your engine? If you have your car set up now and you want to kind of keep that, you can just, hey, what's my cruising RPM at whatever mile an hour? And you can pick that. What I'm targeting, I'm going to target 2,000 RPMs at a rate of 70 miles per hour. That's what my target's going to be. I know my transmission in that is a 700 R4. So first gear is not one. Sorry. Let's try this again. I just wrote on my wall. First gear is 3.06. Second gear is 1.63. Third gear is 1.00. And fourth gear, which is overdrive, is a 0.7. Yeah, I have some notes over here in my cheat sheet. All right, so let's convert our tire diameter, our tire numbers to diameter. So the way this equation is set up is this is a percentage of this measurement, and this measurement is in millimeters. So let's take, first number is 275, which is millimeters. Second number is a percentage times 0.65, and then that's going to give us our height of our sidewall. Okay, sorry, let me explain this. You have a tire. Your rim here, 18. And then you got one sidewall height is going to be your 275 times 0.65. 275 times 65. So 65% of that. That's one sidewall here. And that's in millimeters. Then we're just going to take that and all that divided by 25.4 is equal to, this gives us our dimension, and the 25.4 is millimeters per inch. So we're going to take our 275 times 0.65 is equal to 178.75 divided by 25.4 is equal to 7.037. So let's go 7.04. So if our height of one sidewall is 7.04 inches, so 7, we'll just call it 7. 7 plus 7 plus 18, 7, oh holy moly, I can't write today. 7 plus 7 plus 18 is equal to 32. So our tire diameter is 32 inches. Okay, so we have our tire diameter, we have our engine RPM, our target engine RPM, we have our transmission gear ratio, which we're going to say that's in 4th gear because that's a cruising speed. At cruising, 70 mile an hour, I want to be in overdrive. And then I don't have a transfer case on this one. My transfer case is going to just be 1 to 1 or 1.0, whatever that is, and 70 miles per hour. What I don't have is my rear diff gear ratio. So that's what I want to solve for. Let's put that about right here. What's my gear ratio? So, gear ratio, this is all a units problem. For those of you who do a lot of math, this is all a units problem. So, gear ratios are unitless. But let's start with our tire diameter. 32 inches. Inches don't do us any good. We need to convert that. Oh, well, no, they do. We'll get there in a second. We have 2,000 revolutions per minute times our overdrive is 1 over 0.7. Transfer case ratio is 1 over 1, which doesn't make any difference in this equation. If you have a 4-wheel drive or off-roader and you're looking for your speed at idling, you can put your idle RPM here, you can put your transmission gear, your transfer case ratio here, and you can get that. All right. Let's see, what else do we have? Tire diameter. So if we have a 32-inch tire, we were going to use the equation circumference equals pi times diameter, and we are going to get we're going to turn this into, we need to get rid of our revolutions here. So we want to have inches per revolution. So pi times diameter, we're going to take 3.1459 just because I'm a nerd, times 32, 100.5 inches per revolution. So 100.5 inches per revolution. Okay, we have miles per hour. We have 70 miles per hour. We have a problem here. I have minutes on the bottom, I have hours on the bottom. I need time to cancel out. So we need to flip this one. Hour, 70 miles per hour. Okay, we need to get rid of hours, have minutes. We know that there are 60 minutes per 1 hour. See, cancels out. We'll get to the canceling here in a minute. Now, the next one we need to do is how many inches in a mile. We know that there are 1 mile is 5,280 feet. Let's multiply that by, we know that there is 1 foot per 12 inches. See, I knew that would be in the wrong place. And I think we're good. So let's go back to here. Revolutions, revolutions. Minutes, minutes, inches, inches, feet, feet, miles, miles. We are now unitless. Let's throw this in the calculator and see what it comes out to be. So we have 2,000. Let's divide that by 0.7. So that's how you know your overdrive. And then let's multiply that by 1. Not have to do that in here. Let's multiply that by 100.5 5. Let's divide that by 70. Let's multiply that by 60. Let's divide that by 5,280. And let's divide that by 12. So, which gives us 3.88 to 1. Right there. That's the gear ratio of your differential. Now, you can use this same equation and move things around and solve for any one of these things. If I want to know what my RPM is, I just take this 3.88 to 1 and just simple algebra, I flip it and stick it in here. So if I'm going to do the same equation for, let's just say what my speed is. Let's figure out what the speed would be. So I take revs per minute multiplied by my gear ratio. And here's the thing, is I can do it for any gear. You just put whatever gear it is right here. Multiplied by transfer case ratio, multiplied by inches per, nope, let's do this. Let's keep all of the gear ratios right together here. Let's put our 3.8, nope, did that wrong. Because it's on this side of the equal sign. To bring it to this side, I gotta flip it. And let's see, I was trying to solve for miles per hour. Let's put that down here. Because it is my flipped here, I can go miles per hour. And then I can just say, which is my tire diameter here, inches per revolution, multiply by, that one's gone because we moved it over here. I have to have 60 minutes per sorry. Now we just moved it all over here. Let's see what our units come out to be when we put took this, put it on this side. Let's see. Revolutions, revolutions. Minutes, minutes. Inches, inches. Feet, feet. Look, we have miles per hour left over. So you can put your numbers in here, your tire size, your everything else, and work this out. You can also figure out your gear ratio. You can move it around and solve it. So now that I've showed you how to do all the math on the board, let's jump onto the computer. Let's put this into an Excel spreadsheet, and so we can play with it. So what I did is I took the equation off the board, and I just stuck it right here. So the revolution engine RPM multiplied by 1 over transmission gear multiplied by 1 over transfer case gear multiplied by tires or inches per revolution. Anyway, etc. So, let's look at this. All right, so same thing we just talked about on the board. I also put a calculator in here to calculate our inches per revolution. So 3.89, and the difference between the 3.88 that I got over there and the 3.89 here is a rounding factor because I had 100.5 there, but whatever, doesn't matter. Anyway, so 388, 389 isn't a common gear. The most common are either 411s or 3.73. So because I'm not looking to re-gear my rear end, I'm just gonna buy one that's already done because it's a square body Chevy. The most common ones I can get are 411 or 373. Let's see, okay, if I put a 373 rear end in it, what would my engine RPM be? So I took the same equation that we took, I just flipped it around and reworked it to solve for engine RPM versus solving for differential gear ratio, and I take the 3.89 just for fun. See, it puts us really close to that 2000 engine RPM. What if I put a 373 gear ratio in it? Oh look, I'm at 15 RPM, so I'm 85 RPMs short of my 2000 RPM goal. I'd be pretty good with that, but hey, if you're not good with that, what if I put the 411 in there? Oh, 4.11. There's 411. I'd be at 2100 RPMs. I kind of want to go for the lower, so I'd rather actually have the 3.73. And a good thing because I already bought one. Anyway, and then, well, inputs for speed. I just switched the same equation around and said, hey, if I have at 2000 RPMs, if I have the same tires on it, right? My speed would be 73 miles an hour. Okay, well, what if I don't know my tire diameter? Let's say I know my engine RPM. I know my speed. I want to go 70 mile an hour. What if I want to go 75 mile an hour at 2000 RPM? And my trans gear and my diff ratio. So and then let's talk about how this will affect your vehicle. Okay, let's put a different size tire on this thing. The stock tires that came on the truck, let's see how it'll affect tire and everything else. So the stock tires that were on the truck were actually a 195, 75, 15. Itty bitty teeny tiny wheels. Okay, so, and it was also a 270. It was a 273 rear end. Let's see. Let's put my diff ratio in here. 2.73. So 2.73 at 70 mile an hour. Give me I was at 1600 RPM, almost 1700 RPMs. So if I wanted to have exactly the same driving, like it did stock, what size of tires would I want to put on it? So if I just said, hey, I want 1700 RPMs, let's just for fun, let's go with 1619. Nope, 96. There we go. 1696, like we solved for right there. And let's just say our speed was 70, and our trans gear stays the same. Our gear ratio, if I went to a 373 rear end, I'd actually have to go with a 36-inch tire to get the same thing. And we're not going that big. Anyway, so that's how you can use this calculator for various different things. You can use that same equation that we saw on the board over there. And yeah, so you can use this equation for a lot of different things. If you want to know, hey, I'm going to go to a bigger tire, what's it going to do to my engine RPM? Is it going to make my truck feel differently? Or hey, you take your truck into the dyno, your car, your truck, whatever, into the dyno, and say you look at your dyno, your power curve on the dyno. Hey, I want to be, if I'm towing, okay, this is my peak torque range is right in here. If I want to be towing in the peak torque range, or you're drag racing and you say, hey, I want to be this mile an hour at this RPM, right? You can put in what's my gear ratio, my differential, or what tire size do I need to be with a certain gear ratio. You can work it back and forth and solve for all those different things. So anyway, simple math here. If there are other things that you'd like me to talk about with cars, with car math, let me know and I can make a video on it. I'd be happy to. Leave some comments below and let me know what you think. Hopefully this is helpful to you, and thanks for watching.